Okay, I think we can start now. It's 6:40. Yeah, okay. Okay. Good evening, everyone. Welcome to the second part of the workshop on API development. My name is Jay. I am a fourth year computer science student, and welcome to TGIFHacks number 132. A bit about myself. I am a final year computer science student. Last year, I was the vice chair of NTUSS, and I have some experience on working with backend applications such as building APIs, testing them, and deploying them to various different kind of environments. So this was a two-part workshop, and this is the second part of it. So in the first part, we were primarily concerned about building APIs and learning the fundamentals of it. In this part, we will be working with deployment, security, as well as some other side topics that we may cover if we have some time. So just to go over the agenda for this workshop, firstly, we will start off with introduction, and then we will do a quick recap of the web APIs and the protocols that we learned the last time. Um, After that, we will understand what deployment means when it comes to APIs. And then once we understand that, then we need to learn what is CI/CD. So CI/CD basically stand for continuous integration and continuous deployment. And it is a very important concept when it comes to deployment because we can basically fuse these two things together, which is deployment and CI/CD, to build a pipeline. And based on this, we will have our first programming exercise which will be quite short, but we will do some live coding and how do we actually deploy the API that we built. After that, we will move on to the security part of it. We will give some examples of what security is and then move on to the different kind of security mechanisms that are there. Specifically, we will talk about Oauth 2.0, which is one of the most common and most popular security frameworks out there for securing APIs. And then we will have a programming exercise relating to security. So we will implement OAuth 2.0 in our API, which we built the last time. We will not code out the whole thing from scratch by ourselves because the code can be a bit too much for this workshop. Instead, we will just go over and basically have a walkthrough of the code and understand it from there. Afterwards, I'm not sure if we will have enough time, but if we do, we will cover CORS. It is another very interesting and important aspect of APIs, but yeah, we will see how the workshop goes. And finally, we will close off the workshop with some remarks. So in total, the workshop should take around 1.5 hours, give or take 15 minutes. And we should be able to cover at least till the security part of the workshop in this time. So in the middle of the workshop, if you have any queries, questions, any kind of concerns, anything that you would like to ask, you can go to this website called Pigeonhole and you can enter the code NTUOSS. So from here, you can key in any of the questions that you have, and I have the Pigeonhole website open on my phone, so I'll take a look from there. If you want, you can submit your questions in the Zoom chat as well. Sometimes I just forget to look at the Zoom chat, so I include a Pigeonhole link here. But if you like, you can just yeah, you can submit a question in the Zoom chat as well. That is also okay. And afterwards, afterwards the workshop is over, you can also email me if you'd like. That is also perfectly fine, and I'll be happy to answer any of the questions that you might have after the end of the workshop. So just to be clear, you can go to this website and you can enter this code NTUOSS. All right, so let's start with some of the recap which we did in the last time, in case some of you were not present in the last workshop, or if you if you just have a good idea of the APIs, and it will just be a pretty quick recap of what we did and just a basic understanding. API stands for Application Programming Interface. Interface is nothing. It's basically a platform where two devices communicate with each other. They can be devices or they can be users, or one can be user and one can be a computer. So it's basically anything which enables and facilitates communication between two things is called as an interface. The basic structure of an API can be understood from this diagram. You can consider there are two parts to it. Firstly, we have the web browser, from where which is called the client side, or we can call it at the front end as well. And then we have the server. So this is the server part of it. And this is, we can also call it as the backend part of the application. And in between, we have the API. So the main job of the API is to facilitate communication between the client and the server and provide data and information. So one quick example would be that when you open your web browser and you type, for example, google.com, then what really happens is Google is stored in a server somewhere, maybe in a Google data center. And what happens is that your browser will send a GET request via the browser API to the Google server, and the Google server will return you back the response, which is the Google homepage, which you will see on your on your browser. So you will basically request the homepage of Google with the help of the browser API. The browser API will call the web server. We don't know how that works. We just need to know that the web server will return us with the Google's homepage. And once we have that, that will be returned back to us, and we can then view the website google.com. So just a quick primer on what APIs can be and how they actually work. So afterwards, we talked about web APIs and protocols. So there are many kind of APIs out there, such as framework APIs, operating system APIs, and so on and so forth. But specifically for this workshop and for the previous one, we focused on web APIs. These are the most common type and most widely used form of communication networks. And most APIs which are designed nowadays are based on web standards. So all the examples which I gave in my last workshop previously, as well as the API which we built last time in a programming exercise, is the web API. And this is our focus for this workshop as well. Now, when it comes to web APIs, we follow a very specific standard called RESTful APIs. There are many other standards as well, such as GraphQL or SOAP APIs or XML RPC APIs, but our focus will be RESTful. So again, RESTful is one of the most common and most convenient methods for connecting components and building APIs. A RESTful API is basically an API which follows the REST architectural style. So REST is basically a set of design principles which we have, and any API that follows that specific design principle is called to be a RESTful API. So we can encode the data in many formats. We can have JSON, HTML, text. There are many formats out there, and all the transport of the data is done using HTTP. So this is at this moment the global standard, and this is the most common form of APIs which are out there. Afterwards, we went to the programming exercise where we built the NTU OSS API. So what that API really did was, we started off with the use case that suppose we have an NTU OSS website or a mobile application, and we want to register new users, and we also want to maintain a list of users in our database and display those users anywhere we like. So we started off with a very basic schema. Suppose we have members in our database. So the member in our case is basically a student, and we had three attributes: a student has a name, a school, as well as a graduation year. And then we wanted the API to do two things. Firstly, a functionality to add members, so that we can call the API whenever you want in the website, on the mobile app, or any place else, and add members and register new members. And again, the second facility that we had was to fetch members. So if we want to display the list of members somewhere, we suppose on the website, then we can use the same API again to fetch the members. So we built last time an SQL database, This database was connected to the API, and then whenever we added members, it stored the list of members in a database. And whenever you wanted to fetch the members, we again connected to the same database, and uh, then we had an output of all the list of members in NTOSS. So this is just a recap of what we did last time. So now next in this workshop, we will focus on deploying the API. Now let's just take a step back and see what we did last time. So last time we built the NTOSS API. It was built using a Python framework called Fast API. The framework is really convenient and it helps us to build APIs really quickly without much overhead of writing code. So in the last time we deployed the API to our own computers, that is localhost. So everyone deployed the API to this IP address 127.0.0.1. Now this IP address is called as a special purpose address or the loop back address. What this really means is that all the computers have this address on their own. That is why whenever you started the server, everyone deployed the API at the same place. But the problem really is that this address doesn't allow you to communicate with the outside world. So for example, if someone wants to use our API, suppose, you know, suppose we built a mobile application and then we want to call the API, then we cannot use this address to call the API because this address exists only in our local machine. So basically this address is not reachable. And the second problem that we had is that, even if we figure out a way that this address becomes reachable, then we have to keep our computers running 24/7 if we want someone to communicate with the API. So if I shut off my laptop, then basically the API will not be available anymore because the server is not running on my laptop anymore. So the second problem is, even if we have this address available, then we have to keep our computers running 24/7 so that anyone can call the API whenever they want. And both the things are not feasible. So what we do is we deploy the API to a cloud application platform. Now this solves both the issues. Firstly, we will get a domain name to which we can deploy the API. And when we have a domain name, it is accessible by everyone. Anyone outside this computer, anyone outside this network, basically we can use a web browser to access this URL. So once we have a domain name, then anyone can use the API with the help of the domain name. And secondly, because the server is running somewhere else, we do not need to keep our computers on 24/7. Once we have the domain name and our API is deployed there using a cloud application platform, then we do not need to keep our computers on as well. It will run 24/7 somewhere else remotely, and then anyone can use it. And this domain name can be anything. I just wrote an example here called api.ntoss.com. It can be very well be yourdomain.com/something, or this domain name can be anything. We can buy a domain uh, as well, or we can use a free one as well. But the point really is that now with deployment, the API will be available for everyone to use. Now, there are many cloud application platforms out there to which we can deploy the API. We have Google Cloud, AWS, Azure, Heroku, and many more. This is just a very small list of platforms available. Google Cloud, AWS, and Azure, these are paid. So we cannot use the services of these platforms for free, but Heroku, we can use it for free. I mean, there's a paid plan as well for Heroku, but yeah, there's a free plan as well. So we can use Heroku to deploy the APIs free of cost. One side note is that if you're a student, right, in NTU or I think in any institution, then you can get some free credits of AWS and Azure when you sign up using a student ID. So Later, if you want to play with the cloud platform or anything like that, then you can sign up with your student ID on Azure or AWS, and you can get some free credits, and you can use those credits to basically deploy or do anything with the cloud. So for this workshop, we will be deploying our API to Heroku, because we can deploy it free of cost, and it's quite straightforward. And because there are many options available to deploy the APIs, each option has its own pros and cons. For example, if you want to scale the API, if you want to secure the API, or have different kinds of tiered setups, then one platform might be better than another. Because, for example, say you built an API which is being used by maybe 1 million users at a time. So that is a very heavy load. And, maybe one platform can provide you a better advantage when it comes to scaling the APIs and so on. But for this workshop, we won't have any much traffic. So it will be a pretty straightforward use case. That's why we can stick with Heroku for this time. Now, moving on from deployment, let us understand the next concept called CI/CD. So CI/CD basically stands for continuous integration and continuous deployment. Let's focus on continuous integration first, and then we will move on to continuous deployment. So let us take a use case. For example, we have any repository. Say we have the NTOSS API repository, and we have a group of developers. So what developers do is they commit code to a central repository. So a developer will write some code which represents maybe a change in the data in the code base. The change can be a feature, or they fix a bug or anything like that, but they change the code base while writing the code. So once that happens, they merge it, or they basically commit the code to a central repository. It can be GitHub or any kind of any kind of centralized repository system that is out there. Once we commit the code to a central repository, then we have a thing called as a CI server. So this server runs remotely as well. This server is provided free of charge by GitHub for some very specific use cases, but then other repository systems provide these servers as well. So this is called as a CI server. What the CI server does is basically it builds the program source code, and it compiles it and builds it into a deployable version if that's the case that is required. So the CI server can do a lot of things. Suppose we have a bunch of test cases that we have written for our program, then we can program the CI server to run the test cases whenever developers push some code. And whenever we run those test cases, we will either get a success or a failure. So a big picture is developers write and commit some code. The CS server, once the code base is changed, the CS server will run its tests. It can run tests, it can build the program, or it can deploy or compile a different kind of code based on what we wrote. And once we have all these things, then either we can have a success or a failure. So for example, if you change the code base and some of the test cases broke, then it will result in a failure. So we will know that something went wrong. So this prevents us from breaking the code base, and it basically helps us to fast speeden up the process of integrating code with others, because we will know if something's wrong very early. So a quick example can be, we are working on an Android application, and Android application works on the process of Gradle. So every time we run the application, we need to use the command Gradle build to build the application. And once the build is ready, then we can use it on any Android phone. So we can program the CI server such that whenever there is a change in the code base, then the CI server should automatically build the application and see if it's building successfully or not. If it's building successfully, then it's good. If it's not, then it will return in a failure and the code will not be merged. So this is basically what continuous integration means. The next part is continuous deployment. So suppose we have a success. Say I added a new feature and the code base is working fine. The test cases are passing, nothing is breaking, and the build is successful. So we have the success case. Now, continuous deployment basically means we want to deploy the application to a live production environment. So that consists of basically 4 steps. Firstly, we have the release, and we need to keep in mind that all of these things happen automatically without any human intervention. So CI/CD means that this whole process should be triggered by bots, and we should not, we should not need to manually trigger the processes. So once a code base changes, then all these processes should be automatically triggered. So suppose we have a successful build or a test or a successful CI pipeline, then we will release the software. So release basically means is that we have a final version of the software that is released to the end users. So once we have that release ready, we will deploy it. So deploy in very simple terms can just mean we are deploying it on a live server, or we are deploying the application on a specific environment. And once we deploy it, we can operate it in the cloud or whatever environment we are deploying it in, and we can monitor its health as well. So we can see if the application is working fine or not. So this is not the full picture of CI/CD because we have a process called continuous delivery, which comes in between CI and CD. But for the scope of this workshop, we will not go into continuous delivery. For this workshop, continuous integration and continuous deployment are more than enough to get us started. So yeah, this is the process of CI/CD, which is basically firstly, we build the code and see if everything works fine. Once everything works fine, then we deploy the code on a live server on a production environment, and the whole process should take place automatically. Now, there are many CI/CD tools out there which you can use to build the pipelines. Jenkins, it's a pretty common tool. It's an open source automation server. We have GitHub Actions. GitHub Actions is used to build, test, and deploy code right from GitHub. We have TeamCity. So it's TeamCity is by JetBrains management software. Um, TeamCity and Jenkins, they're quite popular when it comes to building CI/CD pipelines. And then we have Circle CI and GitLab CI/CD as well. So this is just a very small non-exhaustive list, but we have many tools out there to build CI/CD pipelines. So for the scope of this workshop, we will be focusing on GitHub Actions because firstly, it is quite easy to use and quite easy to deploy and build pipelines using GitHub Actions. So, and also we have the code base in GitHub as well. So we can integrate GitHub Actions and GitHub together quite easily using just one single file. So to build the CI/CD pipeline, we are going to use GitHub Actions in this workshop. So just to go over the process of what we are trying to do is we are trying to fuse deployment of our API to a cloud application platform, and we are trying to fuse that into a CI/CD pipeline. So we want to deploy the API and we want the process to be automatic. So whenever we change the code to our API, we want that the newest code should automatically be deployed and should be accessible online. So to go over the process, we have the NTU versus API. And as a developer, I write and push some code to GitHub. As soon as I push the code, it should trigger a workflow using GitHub Actions. So this triggering should be automatic as well whenever I push the code to GitHub. So when the pipeline is triggered, it will get the latest code. So checking out the repository basically means we are getting the latest code from from the GitHub repository. We get the latest code and then we deploy it to Heroku. So the pipeline consists of two steps. Firstly, we should fetch the latest code from the GitHub repository, and then we should deploy it to the Heroku platform. And once it is deployed, then we should be able to access it on a custom domain name that we will have. And this process is automatic. So as soon as we push the code, a workflow should automatically be triggered that will deploy the API to Heroku. And Heroku will host the API to a domain name which anyone can access. So this is the big picture of what we are trying to do, which is basically combining our deployment strategy with CI/CD using GitHub Actions. So now let's try to write some code and have our first programming exercise where we will work on deploying the API to the Heroku platform. So you can go to this URL. So this is basically where the code of the API is, or you can scan the QR code as well. Anything is okay. I will just also paste the GitHub link to the Zoom chat. So you can go there and download the code from there and we can get started on the programming exercise. So let me just paste the code in the paste the link in the Zoom chat. Okay, I pasted the link in the Zoom chat, so you can go to the GitHub directory and go to this web page. So for this workshop, right, you need to have a GitHub account because cloning this repository simply won't work because we will be deploying this using your own account. So what you need to do is you need to go to this URL and you need to click on fork. So you can sign in or sign up on GitHub, and then you need to click on the fork button so that you can have a copy of this in your own account. That is important for this workshop because then you will be able to deploy the API on your own into your own account system. So once you have this web page open, you can click on this fork button and then you can open the copy of this workshop in your own GitHub account. And once you have that, you can clone the repository using either the GitHub CLI or simply writing git clone and copy and pasting this URL. So you can copy and paste this URL into your terminal. And before this URL, you can write git space clone space and this URL. So that will open this repository, basically copy the code of a repository into your machine. And once we have that, you can open it in a code editor of your choice. For this workshop, I will be using VS Code, but yeah, feel free to use any code editor that you like. So open the VS Code file as well. Okay, so we'll take like 2-3 minutes so that everyone can fork the repository and then clone it and open it into your code editor. So for this case, I'll be using VS Code. Yeah, so just to repeat, you need to fork the repository into your GitHub account. And once you have that fork, you can go to this button and you can clone the repository to your computer. So you can use the CLI or simply git clone this URL. So this URL will be your own. So this will be your username and the repository name. Once you have that, you can open it into your VS Code account, VS Code or any editor that you want. Yeah, you can use GitHub desktop as well. Anything is okay. The only thing is that you should first fork this repository and then use the URL that you will get from your account to clone it. Cloning my repository will not work in deploying it to the web. So yeah. Okay, so I hope everyone is able to fork and clone the repository into their own accounts. Um, is there anyone who is still forking and cloning the repository? We can wait some more time if that's needed. Okay, I think everyone has done so far. All right, so the next thing that you want to do is okay, let me just open it. We need to go to the Heroku website and create an account. So you can go to the Heroku website and from there you can either sign up or log in if you have your own account. So let me just paste the link for Heroku in the Zoom chat. So you can open Heroku and here you can either log in or create your own account. So I'll just wait another minute so you can create an account on Heroku. It's everything is free here on Heroku. So once you have an account created, you can go to your dashboard, which is basically dashboard.heroku.com, or you can just click on this link and go to the dashboard here. So I have these 4 apps here, but yeah, you won't have any app. It will be just empty, but you can create an account and go to the dashboard. Okay, now, okay, has everyone able to follow the workshop so far? So any issues, uh, anything, any query or anything that you might have? Are you everyone able to create a Heroku account and um, follow the workshop till here? Anyone who's not able to do anything, can just feel free to um, leave a message in the chat or in Pigeonhole, and I can take a look from there. If not, then we can move forward. So once you have your Heroku account, you need to click on new and then create new app. Once you go there, you need to name your app. So we can name it anything that we like. You can name it, say, NTU OSS API, your name, because this name needs to be unique. So if everyone uses the same name, then it will not be available. So this name can be anything basically. So it can be NTU OSS API, and you can yeah, right, this is also available. So yeah, anything works. And once you have the name, you can click on create app. So once you create your app, you will see the app with the name here like this. So you will see a page like this once you have the application created. So anyone having any issues creating the application on Heroku so far? Okay, perfect. So I think everyone is able to follow the workshop so far. So the next thing we want to do is we need the API key. So you can go to your profile here and you can click on account settings. So you will see your basic details here. In the account settings, you will see the API key. So what you need to do is you need to reveal this API key and then copy it. So I have already done it, but yeah, you need to reveal the API key and then copy this thing. And once you have copied that, then you need to go to your repository, which is the one which you forked. And then you need to click on, let me just sign into my GitHub account so I can just show you. Okay. So I have signed into my GitHub account here. So yeah, once you have your forked, you can go to your forked repository and you can click on settings. In settings, you go to the secrets tab right here. And in secrets, you can go to actions. And then you will see a column called repository secrets. So you need to click on new repository secret, this button right here. And we need to have a secret name. So the secret name should be Heroku API key, exactly like this. And the value should be the API key, which we just copied right now. So once we put this name here as Heroku API key, as well as the value, which is the API key that we had, then we can click on add secret and it will add a secret to our GitHub repository. So then you will see a secret like this. So we'll have the API key and we will also have the secret, which is the key which you just put in right now. So, okay, so there's a question, where do we get the API key from? So you can go to your Heroku account. So suppose we were in the dashboard right here. You need to click on your account settings right here. And once you are in the account settings, we can scroll down and then we have the API key here. So you can click on reveal, that will reveal your API key and copy, and you can just copy this string, which is the key. So this will help us in deploying our API to Heroku using GitHub. So we are basically connecting GitHub and Heroku using this API key. Okay, just all right. If everything's good so far, then we can move ahead. So this was just the basic setup. Now we can write the code to actually deploy the API whenever we push some changes to the code. So we can go back to our code editor, and what we need to do is we need to change the branch. So there are many branches in the GitHub repository, and we need to change to the deploy branch. To do that, you can click on the, so there's a branch icon at the bottom left. You can click on it, and then it will show you the branches that are available. And we need to go to the deploy branch. So you can go to the deploy branch right here. So here's the deploy branch. You can just click on it, and it will change the code to the deploy branch. All right. So once we are in the deploy branch, then we can, so the code in the deploy branch is basically exactly the same what we had the last time. So I have not changed anything. This is, again, we had a very basic API that had 3 functions. We can add a member, we can add a member by ID, and then we can get all the members, or we can get a specific member by ID. So this is exactly the same code that we had the last time. Then what we need to do is, so now let us start by creating the pipeline itself. So we need to create a new file, and the file name should be exactly what I write here, because that is the convention that GitHub uses to recognize that we are trying to build a CI/CD pipeline. So we need to write a new file with the name .github slash workflows slash main.yml, and I'm using forward slashes here. So .github slash workflows slash main.yml. So I'll just copy and paste this in the Zoom chat as well. Yeah, and you can just create the exact same file. In the root directory. So we are in the root directory, and I already have that .github slash workflows slash main.yaml. So yeah, this is some code that we have for the CI/CD pipeline, and we will go through it line by line. And it's pretty small, just 25 lines, but it basically tells GitHub to deploy the API to the Heroku platform. All right. So let us start. Firstly, we have the name of the workflow. It can be anything. For here, we have the workflow name as deploy. We can write it as deploying the API. Then we need to specify when do we want to trigger the workflow. So here I write whenever I push the code to the branch deploy. So we switch to the branch deploy, and I need not specify this, but I'm specifying it here that whenever I push the code on the deploy branch, then I need this job to run. That is basically the meaning of this code. So whenever I push the code to deploy branch, this job should run. So I'm specifying a job called deploy, which runs on an Ubuntu container. So basically, we are running the job on a Linux container. And what we do is the 2 steps which we mentioned in the presentation. Firstly, we check out the repository. Checking out the repository means we are basically fetching the latest code which is available in GitHub. And then we deploy the API to Heroku. Now, this is a very simple GitHub action that is available uh, open source by someone, and we can use this action to deploy the API. So it's basically, you can think of it as a package. We are using this package to deploy the API to Heroku. Now, with this package, we need to specify 4 things. Firstly, we need to specify the API key, which we just had. So this is a GitHub convention again. So we can write secrets dot, and then we write our secret name. So if you recall, we named our secret Heroku API key. in while we went to the settings, secrets, and then added a new key here. So we are just specifying a variable called secrets.heroku API key, and by specifying this, it will fetch the API key using the GitHub Secrets Manager, which we just configured right now. So this with this we can directly put the API key here as well, like in brackets, and we can put the API key. But then again, it's not secure because you are committing the code to a public repository, and everyone will have access to your API key, which is not secure. So instead, we hide the API key in secrets, and then we use a variable to fetch the API key whenever you want. Let me just remove the, yeah. Yes, there's a question in the Zoom chat that, so yeah, so okay, so the question is about this file only. So once we have this main.yml file, then this is the code that we put in the main.yml file. So once we create that workflows slash main.yml, then we can go to this file and then we write the code in this file only. So writing .github slash workflows slash main.yml is a format which is mentioned by GitHub only, that this is the only way we need to name our file such that we can run the CI/CD pipeline. So I hope that's clear. So all right, perfect. So now yeah, so this package needs four things. We mentioned the API key here, then we need to mention the Heroku app name. So here you need to mention the app name which you just entered in Heroku. So if you forgot, you can go back to your Heroku account. You can go to your dashboard and you can see the name of the app that you created here. So for me, it's NTU OSS-API-workshop. So you need to enter your app name here. And then secondly, you need to enter the email ID from which you signed into your Heroku account. So this is my email ID, but yeah, you can put in yours, which you use to sign into the account. And then we need to replace this with your app name again. So this should be your app name, which is exactly this one. So for me, it's NTOSS API workshop. So I just put this, and then this should remain the same. So this is basically the domain name of our API, from which it will be publicly accessible to anyone. So .Heroku app is basically what the Heroku app assigned it to us, and this is the name which we put in. So just to give a brief overview, what we are doing is whenever we push the code to the deploy branch, we want GitHub to fetch the latest code from the GitHub repository. Once we have that code, we want it to deploy to Heroku using this API key, this app name, and our email ID. So it will basically deploy the API to this application which we created, and it will use the Heroku API key. So far, so good. Any questions or anything that is confusing? Just please let me know, and I'll be happy to answer anything. Okay, so I think so far it's clear for everyone. All right. So once you have written this code, right? So you then need to commit the code to the GitHub branch. So I'll just save it. And then you need to go to the file that you modified and then push the file to your forked repository. So once you do that, you can just, I am using VS Code here, so I just stage the changes. I can write a commit, CI/CD pipeline. I can commit this code, and then I will push the code. So once we push the code, we can go back to the GitHub repository that we had. Let me just have the other window here. So this is the GitHub repository that we had. Uh, we need to switch to the deploy branch, and then you will see very interesting. So now you will see that there is a yellow icon at the top, which says some checks haven't completed yet. It says deploying the API. You can click on details. So now you can see that this pipeline automatically got triggered. So as soon as I push the code, it set up a job for us. So what this job is doing is basically is checking out the repository. And once it is checked out, it is deploying the code to the Heroku platform right here. So yeah, in your GitHub account, you should be able to see uh, this pipeline running when you push the code to your GitHub account. So you can click on details here, and then you should see a bunch of steps running here. So for me, it says the deployment is complete. So hopefully everyone is seeing the same in their GitHub accounts as well. So can I get a confirmation from anyone, a +1, anything, or a thumbs up, just to make sure that everyone is okay till this part, everyone is able to push and then able to see this GitHub pipeline running in their accounts. Okay, so I got one message that no pipeline is running. Okay, so if no pipeline is running, we just need to make sure one thing is correct. So if you go to your deploy branch, you should be able to see a folder exactly named like .github/workflows. And you should go inside this folder and you should see a file main.yaml. So can I just confirm that you are able to see a file till here? Is everything the same till here? Okay. Then maybe the push was not successful because we did not change anything in the file. So if that's the case, then you can maybe rename it. You can rename it anything you like, Cicd. And once you save it, then you'll have a file changed here, because we are only triggering the pipeline on a push. So we need to push the code. So you can change the name here, and then you will see the changed file right here. So you can then stage and commit it, and then you can push the file, and hopefully then you should be able to see a pipeline triggered right here. Can I get a +1 or a thumbs up from anyone else as well who is able to follow the workshop till here and deploy the pipeline using GitHub Actions? Or if you have any issues or any problems or any errors, you can post it in the chat as well. We can figure something out. So I'll wait here for like 1 or 2 minutes so that everyone can figure out how to um, follow the workshop till here and see till this part, which is setting up the CI/CD pipeline to deploy the API. So in the end, you should see a tick mark, a green tick mark, which indicates that the API deployment was successful. So if you can see the green tick mark, then that means the deployment was successful. All right. So, all right. So once we have that, we can go back to the Heroku account. So you need to open the app right here, which is the one you created. And you will see that, so it says today at 7:30, I deployed uh, the new code. So in the Heroku account, you can go to open app, which is right here. And then it will open the application in a separate tab. So you can see right here, you have your own URL here. This is what you named your application. And then you can go to this URL and you will see the API deployed live. So if you would like, you can go to /docs, and then you should see the same interface which we had the last time, except it's deployed live on a server, which you can access from any place you want. So if you want, you can access this URL, which is my API for NTOSS, and you can use it in your programs to access this API and call functions here and there. So this basically covers the deployment part, and till here, everyone should be able to open the API platform in their own domain names, which is basically the application name which you created, .herokuapp.com, and you should see the fast API instance that we created here. All right, perfect. It's working for some people. For others as well, is there any issues, any problems till here? Is the API deployment working so far? Okay, perfect. All right. So so this basically completes the deployment part of this workshop. So now we have that API which is deployed live on Heroku, and every time we change any code, for example, we go to the main file, we add a few more methods here and there, and whenever you push the code, it will automatically trigger a workflow and deploy the latest version of the code to the Heroku website. So let's go back to the presentation and to the next part. All right, so the next part is about securing the APIs. So before we go deep into securing the APIs, let me just give you a motivating example as to why we need to secure the APIs in the first place. So consider the following example. So AWS is a company that provides us with a lot of APIs. So one of their APIs is called Celebrity Recognition API. So what it basically does is that you can send in an image of us of anyone, and then the API will identify the person in the image if they're a celebrity or not. So in this case, the API is able to identify this person with this probability, and it will return you the text response that, okay, this person is this, the name of the person is this. So this API is basically used to recognize celebrities from images. So you can have any application which will send an image, and once you have that image, the API will return a response saying what celebrity is in the image. So this can be a dummy URL that they provide, and in this URL you can submit an image, and then it will return you back the response. Now, why do we need credentials in the first place to begin with, and why do we need to secure the API? So in a typical API use case, we will have a thing called credentials, and we will need to supply these credentials along with the request to access the API. So Amazon doesn't provide us with this API for free. They charge us and they bill us based on the usage. Now, how do they do that? Is that they will say that, okay, you can make 1,000 requests, and for 1,000 requests, we will charge you, say, $5. The amount can be anything. Now, if they have this URL, right, then anyone can use a URL to use the API. But then again, the API should not be for free. So once you create an account with AWS, they will give you some credentials. We will talk more about credentials later. They will give you some credentials, for example, a username and a password, and you will supply your username and password along with the request. So once you supply your username and password, then they will record that, okay, person X used the API thrice, and based on their usage, they will bill you accordingly. So this is just one example on why we need to secure APIs and why we need credentials in the first place to begin with. Now, there are many ways that credentials can be formed. The most basic method is called basic or bearer. So this is a very straightforward and easiest method. In this method, we are basically providing the API with two things, which is the username and the password, and they're encoded in base64. So the important thing to remember is we are providing the API with a username and a password. In the bearer form of authentication, we use it is an bearer is an HTTP authentication scheme, which we will talk about later. But essentially, what it does is that it provides us with tokens, and we can use the token to access the API. The next common form of authentication is API keys. So API keys is something which we just use as an authentication to log into a Heroku account. So if you recall, we copied the API key from the Heroku website, and we used that API key in the GitHub account to connect to Heroku. So an API key is a unique string which is given to you, which is unique to you, and you can use that unique string to identify yourself and use services. So we just use API keys. That is another common method for encryption. Then we have OAuth 1.0. It can be used for authorization. It works by providing access tokens for any form of identification. OAuth 1 was popular before, but it is something which is no longer used as much as it used to be before. And finally, we have OAuth 2.0, which is also known as the bearer token scheme. And this is the one which we will talk about in this workshop. So it comes with these 4 different flows. We do not need to go too in depth about the various forms of flows. It is out of the scope for this workshop, but just for reference, for this workshop, we will be focusing on the resource owner password flow. So OAuth 2 is hands down the best choice for identifying personal user accounts and granting proper permissions. It is used by almost every tech company, or even I would say every company out there to authenticate. So just to give you a few motivating examples, Google, Meta, GitHub, LinkedIn, all every time you do a single sign on a website or any kind of logins, then OAuth 2 is used to identify you. So they have their own APIs, and then these API use OAuth 2 mechanisms to encrypt and identify who the user is. So in this workshop, we will be focusing on OAuth 2. Now I think this is one of the most important slides for this workshop. And this basically shows us a flow of how OAuth 2.0 works. So it is a bit simplified here, but it will help you to get an overall understanding and conceptual understanding of what OAuth 2 is and how it actually works. So to begin with, there are 3 identities that you can consider. Firstly, we have the front end, which is an application. So suppose the front end is a mobile application that you built and you want to use an API, which is secured by OAuth. So this is the application that in our case can be the NTOSS mobile app, which we will use to call the API. Then we have the user, which is you. So suppose I am using the API, and then we have the API itself, which we built. The API is called the resource, and then there is an authorization server as well for Oauth. But for simplicity, we are going to combine these into one. So you can consider that we have an API. That's it. So these are the three identities. Now let's review it from a simplified point of view. So firstly, the application will ask the user for their user credentials. The user will type in their username and password in the front end. So I will provide my username and my password to the application. So once the application has my username and my password, what it will do is that it will call the API authorization scheme, and it will get an access token from me. A token is just a string with some content that we can use to verify who the user is later. So you don't need to care too much about the token thing. You can consider it as basically it's like a unique string, which is given by the API, which can be used to identify who you are. So just to repeat, the application will ask the user for its username and password. Once you provide our username and password, we will get an access token from the API. All right, then we have this access token. So now suppose I want to access the API itself. Say I want to send an image and see who the celebrity is, or I want to use the API endpoint. So when I use the API, it will say that I'm not authorized because I don't have the access token. So along with the request, I will send the access token to the API. And once we have sent the proper access token, we will get back the resource, which is the API response. So if we are not authenticated, we will not get a resource back. The API will just say that the user is not authenticated. But if we provide the API with the access token, we will get back the API output as well, which is the protected resource. So this is basically in a very simplified way of how OAuth 2.0 works. I'll take a pause here to make sure that this is clear for everyone. If there are any questions, I'll be happy to answer them. So just to reiterate, we will ask the user for the username and password. With the username and password, we will get a token. And with the token, we can access any protected resource that we would like. All right, if no questions, then we can move on to the next slide. Now let's talk a bit more about tokens and what they are. So a token is just a string with some content that we can use to verify who the user is. And bearer, so token is in a specific format. So when we talk about tokens, the format is we first append the word bearer to it. It's basically a specification. You don't need to worry about why we are using the word bearer or what it is. You can just consider it as a specification that before the token value, we need to append the word bearer to it. And then we need to have the token value itself. So the token value can be any string. It can be as simply as my name, which is J. So I can just write bearer J, or I can write any string I want. So this is any string that can be a token, which is a unique identifier to identify me. Then there is a second category called JWT tokens. So JWT is an encoding standard for tokens that contains a JSON payload. And we don't, for the scope of this workshop, we don't need to go very in depth about what JWT tokens is. We are not going to use this in our workshop. We will use the simple token, but you can consider it as a more secure and a more better way, because this is a signed token with a specific validity period. So most organizations will use a JWT token to identify you, but for simplicity, we are going to use a basic token, which is just bearer space any token value. So this is a bit about tokens. If you would like to learn more about JWT tokens, you can click on this link below. So it goes to jwt.io. And from here, you can play around and see what JWT tokens really are and what they really do. But we do not need to go too much in depth about what JWT tokens are. So if that's okay, then we will go on to the next programming exercise, which is we will secure our API with the help of Oauth 2.0. So again, you can go back to the same repository, or you can scan the QR code here. So again, I'll take a pause for 1 or 2 minutes so that everyone can clone the repository, or if you have already cloned, so that's perfect. So you can go to this URL and clone the repository for securing the API with Oauth 2.0. So let me just go back to the GitHub account. Yeah. So yeah, you can go ahead and clone this one. All right, so if everyone has cloned it, we can go back to VS Code and we can change the branch again. So just okay. So now you can go back to the main branch, which was the default one. You can just work with this one, or you can go to the security branch as well. Both contain the same code, but for this one, I'll just go back to the main branch. And you can see there are two folders on the right, on the left, sorry. We have the part 1 and part 2. If you go to part 2, there are 3 folders: course, deploy, and security. You can go to security, and this is more or less the same code that we had the last time. So it's exactly the same: database.py, main.py, and schema.py. And yeah, we can open the main.py file to understand how are we securing the API with Oauth 2.0. So we can go to part 2, security, and main.py to open this file. So I'll again just wait 30 seconds so that everyone can go and open till here. All right, so let's move on and try to understand the code of how we actually secure the API with Oauth 2.0 standard. So the first thing we need to do is we need to create an instance of Oauth. So this method is provided by Fast API, but what really we are doing is we are creating a password scheme. That means with this method, the user needs to provide a username and a password to access the API. So we just create an instance right here. All right. If we scroll down a bit, so this is basically all the previous code that we had. Nothing new here, but we can scroll to line number 71. And yeah, so this is the code for securing the API itself. So here we can see that we have created a fake user database. This should ideally be somewhere stored securely, but in for the sake of simplicity, we are just creating a dictionary, and we are storing the details here. So in this, we have two records. Firstly, it's my name. So I have a username, I have a password, and then there's a field called disabled, which I set it to false. And then I have another user, Alice. We have a username, we have a password, and then we have disabled the user. So we say disabled true. So these are the two users we have in the database. So suppose you're using the API and someone registers for your API. So you give access to your API to only these two users. So these two users can hit your endpoints and access it. So this is what we are basically trying to do, is create a user database which will keep track of who is authorized to use the APIs. So in this case, this is these two people only. All right. Once we have that, we will create a corresponding user model. So this is very similar to the model which we created last time. This is necessary because Fast API will fill the model and use the model to authenticate users. So again, it contains the username, email, name, and whether the user is disabled or not. So this is pretty standard, but it's just for the Fast API instance to make sure that they can validate the user data. All right. So now let's go to the main function, which is the login. So if you recall from the diagram, let me show the diagram. Okay, so the first thing we need to do is we need to ask the user for a username and password. And if the username and password is correct, then we grant them an access token. So let's do that in the code. So here we say we will the we will declare a new endpoint called token. So what it really means is that we will return the user with a token. And for this one, we will ask the user for a password request form. So part of password request form is really simple. It needs only two fields, a username and a password. So based on this, we will extract the username supplied, and we will get the corresponding record from the database. So suppose if I supply my name Jay Gupta here, then I will try to get the record corresponding to Jay Gupta in this variable. So if I say my username is Alice, then I will get this record using this get function. And again, if I say a username which does not exist, then this thing will be empty. We're just getting the record from the username which you provided. So if the user name does not exist, if this thing is empty, then we raise an exception that we have entered an incorrect username. If not, then we will pass the key and values into the user in DB model. So this is the model which you created the last time. So that inherits this model. So not going into too much depth, what we are doing is we are filling this model based on the username. So if the username is correct, then we will fill the username, email ID, full name from this dictionary that we had. So now we have the user object. Now we will check for the password. Now, a traditional way to store or deal with passwords is hashing, but hashing is something which is again out of the scope of this workshop. So what we will do is we will create a fake hash function. You do not need to go too much in depth about it or worry about it. But what we are doing is, again, we are fetching the password, which is provided from the user. And then we pass it to a function called fake hash. Fake hash will just append the string fake hash to the password. It should be a proper hashing function, but again, it's not required for this workshop. So we will just use a fake hash function. And then we will match if the password is same or not. So suppose I provided my password as secret. So the hashed password should be fake hash secret. And if my password and the password which is stored in the dictionary is the same, if not the same, then it will say that I entered an incorrect password. But if the password and the username are both same, then I will return the token to the user. So the token should be something which is hashed and secure and unique. But for simplicity, I am simply returning the username back as the token itself. So if my username is Jay Gupta, then I will return the token as Jay Gupta only. I will not hash it or use some unique string value. For simplicity, I will just return my own name itself. So this is basically, we are trying to secure the API, and we returned the token to the user. So I hope till here it's clear. What we're trying to do is that we are trying to get the token from username and password. All right. Let me show you the next part. Now we will secure the endpoint. So if we recall then that we have 3 endpoints in the API, we can get the member list, or we can get a specific member. And then we can also post a member. So what I want to do is that if anyone is able to get the member list, that is fine by me. So in this use case, I'll be like, okay, anyone can fetch the member list, that is no problem. But only authenticated users should be able to post or create new members. So that is the use case that I'm sticking in this workshop. So I just want to secure this endpoint, which is posting new members, because I only want authenticated users to be able to post members. So what I will do is I will add this line here. What it will do, that it will get the current active user. If the user is active, then this endpoint will get unlocked. Otherwise, this endpoint will be locked. So this is again a function, get current active user, and we can go to the function definition here. It's pretty simple. So this current active user, it depends on get current user, and get current user will just return us the current user which we just used to log into the API. And we will check if the user is disabled or not. So we will check the user disabled using this field, disabled, true or false. If the user is not disabled, then we will return the current user. So just to reiterate, we are specifying that we want the current active user. And once we get that, then we will unlock this endpoint. So in terms of the presentation that we had, let me just go. Okay. So we got the token so far till here. So we have the token. And then with the token, we are able to get the protected resource because we signed in using our API. So in simplicity, we need our username and password to log into the API. So let us try to run this code and see the whole thing in action. So we have the terminal here. You can open a terminal and you can go into a virtual environment. If you do not have it open, that's okay. I will just open it myself right here and show you how it looks like. So let me go to security. Okay, this is the correct one. Let me try to run the app. So it's running. Let me show it. It looks like. Okay, so it's running locally 127.0.0.1. So this is again the same fast API instance that we had before. All right, so two things new that we notice here. Firstly, there is an authorize button. And secondly, we see a lock on this endpoint, which is basically posting members. So get calls are unlocked, but posting is something which is locked. The other one is all okay. So let me just show you. If I want to get members, I can click on try it out and execute. And I get an empty list. So that means this is working. This is working fine. But if I want to post members, if I go to post, I will Suppose I want to add a new record. I will say SCSC, click on execute. So here I got a response saying not authenticated. So that means I cannot post unless I am authenticated. All right. So to create a new record, we need to authenticate ourselves. Now, how do we do that? I can click on this authorize button right here. And here it says the available authorizations are OAuth to password bearer. So I need to enter my username and password. So from the dictionary, if we recall correctly, my username is Jay Gupta and my password is secret. The hash thing will be added automatically. So here I will write in my username and my password as secret. So just to demonstrate, if I write some random strings and I click on authorize, then it will say authorization error, bad request. So I will put in my correct password and click on authorize again. So now it says I'm properly authorized to use the API. So I will close this. Now you can see this lock is now secure. So again, this is the same post request I have, and I'll try to execute it. Now I got a response with the code 200. That means this is successfully executed and this record is inserted into the API. So if I do a get call here, I click on execute, then I get this record from the API. And I was only able to post the record because I was authenticated into the API. Now this is from the API UI. We can also try to do the same thing in Postman or in any other coding language. So if we try to code this, so suppose you're building a Python application and you want to use the API, then there will be basically two API calls that we need to do. First API call, we need to obtain the token. In the second API call, we need to obtain the resource. So just to demonstrate it step by step, the first API call is getting the token. So I can click on try it out. I will type in my username. I will type in my password, which is secret. I will click on execute. Now this returns me with my token. So this is a very simple use case. I'm returning my username itself, but it will return me with a bearer token. And once I have this token, I can use this token to access all the resources which are protected. So let me demonstrate the same in Postman so that it is more clear as to what is going on. Okay. Just copy and paste the URL. Okay, we can open a new tab in Postman right here, and we can have a post request. In the body, I can type the name, the school, and the graduation year. And then I just remove this. This is some pre-configured things. Okay. So I just type this and I click on send. Now I get a response saying not authenticated, which is the correct response. To authenticate myself, I will go to this authorization tab right here. In the authorization type, I will select OAuth 2.0 right here. In this one, I will configure a new token. So I will name the token as token, and then I will use password credentials. And then we need to make the first API call, which is to get the token. So if you recall, to get the token, we have the endpoint called /token. So I will set the endpoint that we need to go to this /token. Client ID and client secret, they remain empty. And then we have a username and password. So the username should be Jay Gupta and the password should be secret. So I have my username and password here. I will leave the scope empty and I will click on this button which says get new access token. Click on it, it will say authentication complete. So that means it is able to get the token from the token URL. And this is the access token that I have. And I will click on use token. So now I have put in the token right here. When I try to execute this request again, now this request is executed successfully now. So uh, this request was only executed when I put in the correct token here. So just to show you how to do this programmatically, you can go to this code type right here and you can select whatever language that you prefer. So for example, I'll say Python. And this is how you make the API call. So in the headers, so we have the payload here, which is what we're trying to insert. In the headers, we have the thing called authorization. In authorization, if you recall, we have the word bearer space the token itself. So this token we obtained from another API call. So in reality, we will have two API calls. Firstly, we will have an API call here to the token endpoint. And then we will have a token from the token endpoint. And then we will use this token right here to make the second API call, which will return us with the response. So this is just a quick overview as to how do we use OAuth 2.0 to secure our APIs. So yeah, so we can try with the second user as well, which is Alice. So we see Alice is disabled. That means she is not allowed to authenticate herself. We are checking the same here. If the user is disabled, then we raise inactive user error. So let me try it in Postman. I will configure a new token. I will change the username to Alice and I will key in her password, which is secret2. And then I will click on get new access token. So now we have that Alice access token. And then we click on send a request again. So now we get a detail saying inactive user. So with this Alice token, we're not able to send a response because this user is not active. So again, we can have like a big database of users who are allowed, and then only those users can authenticate into the API and then use it. So this was the programming exercise about using OAuth 2.0 to secure the APIs. Let me go back to the presentation. All right. So the next thing that we had was course. At this moment, in the interest of time, I think we shouldn't be able to cover this part because this will take some time. But I will upload the slides and the notes to the GitHub website on my repository. So if you like, then you can take a look there, or I will provide you some resources in the end as well for course. But it is again really interesting, and course is something, if you work in an enterprise setting, then most likely you will encounter course error while working with APIs. So if you have time, please take a look at course. It's something which is a really interesting concept, and it's something which is good to know. So just to close off the workshop, APIs form the backbone of most applications. So they decouple the front end and the back end parts, and they are used to connect them together. And from this workshop, right, I hope that you have a good idea that development and consumption of APIs is one thing, But along with development of the core functionalities, such as adding or deleting members, these parts such as authentication, authorization, deployment, specification, and all those, these are also really crucial parts of building APIs. They take up a lot of time, and authorize, especially the security part, is something which is really important. So these are the things which often get ignored when we are working on a personal project. We only care about the functionality, but authorization and deployment are something which are also really good to have. So if you are keen to know more about APIs, I really recommend that you go through Spring Boot. It's a platform, it's a framework in Java as well as in Kotlin, or you can use the Flask or Fast API framework, which you use in this workshop. They are available in Python. So if you know these frameworks, then you will have a really good understanding of how to programmatically code APIs. So just to give you some more links, if you would like to know more about CICD, Oauth 2.0, and its corresponding, the organization that maintains all the standards, you can click on these links. If you want to understand JWT tokens, open API specifications or cores, we have some links here. And then OData is also something which is really interesting. It is a specification for REST APIs, and the link is here as well if you would like to know more about OData. So with that, I would like to conclude the presentation and the workshop. Thank you so much, everyone, for sticking till the end of the part 2 of this workshop. Some parts might have been confusing, some parts might have been easy, but I hope with this you have at least a basic idea of how to deploy your APIs onto the internet, as well as how to secure your APIs. So I'll be here in the Zoom call for the next 5 to 10 minutes. If you have any questions, any queries, feel free to post it in the Zoom chat, or you can post it in the Pigeonhole as well. Thank you, everyone. Have a good day.